Hi learners, this session we are going to deal about the various encoding techniques for available for converting your categorical values in the dataset to a numerical value. So talking about this, it is a very basic and an important concept in machine learning domain since most of the machine learning algorithms or most of the models that are in the machine learning domain uses only numerical values for its computation. But on the other hand, the user cannot be restricted to use only numerical values as an input always. Sometimes the convenience goes better. Like let's say if you want to get the input as the sex of the person who is using the system, be it a male or a female or other, you cannot restrict or you cannot inform the user to give 0 or 1 or 2. Okay, rather it's a comfortable way to represent the values of the attribute sex to be male or female or other. So when the data gets represented in such a string format, which we call it as categorical value, while moving towards machine learning model or modeling using machine learning methods, we need to change those categorical values into numerical values. So that's what is going to be the talk of this session. So this is the agenda. So we'll see what a categorical value is, why encoding is required, the different types of encoding that is available, and as usual we'll move on to implement the same concept using Python. So coming to what a categorical value is, as we have discussed, it is just string values that are getting stored as components of your features or what we call as your attributes. The data set may have multiple features. So let's say if this is assumed to be a data set, you can have feature A, feature B, feature C, feature D and so on. And these we call it as the columns or what we call as the features or attributes. So the entities are getting stored, the details of these features for the particular entity 1, entity 2, entity 3. Otherwise you call it as experience in whatever way it could be taken up. These are what we call as the experiences, which is written on the rows. The value that you are going to store here, okay, may be a numerical value which is integer or floating point, or maybe a string also. When it is a string, there needs a necessity for converting it into numerical. So when a particular feature has its value in the format of strings, we say that to be a categorical format. Let's say if it is MFO, we say this to be your categorical value. So what is a categorical value? In short, it is the features or the attributes that have strings or categories as their values. So those attributes are what we call as categorical values. Then how these values are represented? There are basically two formats in which you can represent your categorical values. One we call it as the ordinal, second one we call it as the nominal. So in either case. So what is a nominal value? Let's say if I am representing the sex of a person to be male, female or other. So whatever it is, there is no relevance between or hierarchy or ordering between male or female or other. Okay. So it stands as a value. Male means male, female means female, other means other. So it doesn't, we don't have any ordering among the attributes, in which case we call it as nominal. The next comes your ordinal. If in case, if you want to store the feedback of this session, let's say, okay, if I'm going to ask you to rate my session on a 5-point scale starting from A to E, where A stands for the high marks or E is the worst. Okay, so you will have A, B, C, D, E as the values, where actually there exists an ordering between the values that you are going to store for an attribute, in which case we call this as to be ordinal. So when you are going to have the categorical values in a feature or an attribute column, it could either be of nominal type or ordinal type. Some examples I have quoted here. The grades of a student, let's say A, B, C, D, E. So that is again a categorical. The branch which a student belongs to, CSE, ECE or anything, maths or physics, anything. The area where you live in, of course we need to store it as a string. The color of the shirt you wear. So today what color, be it a bright yellow or a red or a green or whatever it is. So this is the feedback of my session. Hopefully it should not fall below C. So these are the examples for the categorical value. Moving on, why encoding is required. We know that features may have strings or numbers as per the user convenience. See, we want to get input from the user, okay, and we need to the users needs to visualize your data set. So the inputs are received from the user and the users again back they have to visualize the data set. So it's mandatory for a quicker and a comfortable representation in the data set. So, and hence you can have strings. So while the strings are there, many machine learning algorithms on the other hand accept only numerical values. Let's say when you are talking about the perceptron, it needs the value only in the numerical format, right? So some algorithms like decision tree may accept both categorical as well as numerical, but on a wider scale, if you think of the major algorithms, it accepts only the numerical values, and hence the encoding is required to convert these strings to numbers. Coming to the different encoding schemes available, there is no limit on the type of encoding schemes. You and me know well. I am going to concentrate only on the basic encoding techniques. First comes the label encoding, then one-hot encoding, dummy encoding, hash, and then binary encoding. These are the 5 we are going to talk about. The label encoding, as the name implies, for every label of the value that you have in a feature column, we are going to encode a value. So this is most applicable for nominal values. Let's say you have male, female or other. Okay. So male could be represented as 1, female could be represented as 2, other could be represented as 3. So this is most useful in case of when the features or the attributes have nominal values, okay, like this. So what is label encoding? Every label in the feature value of the feature or the attribute column will be labeled with a particular numeral. And coming to one-hot encoding, actually the problem with this kind of scheme, or that is the limitation we should say, is that when you are representing with 1, 2 and 3, of course when it goes for numerical computation, there may exist a weightage, an increased weightage for others than male. Okay, so there is no concept to restrict that, and hence we move on for one-hot encoding. So what we do here is, so I'll be trying to create as many columns as the number of values of a particular feature. Let's say if this feature has 3 values, 3 different columns will get created. Male, female and other. So if the first person is male, it will have an entry like 1 and the others will be 0. If the second person is female, so it will have 0, 1, 0. If the third person is not a male or a female, so I'll be writing 0, 0, 1. This is what we call it as one-hot encoding. So in one-hot encoding, the number of columns will be created as per the number of different values you have on the category or the feature. Then comes your dummy encoding, a slightly different concept to improve the storage mechanism is what we call as dummy encoding. Here, so we know that if a particular value doesn't belong to any of the category, let's say if I'm going to hold only an M and F, if that doesn't belong to M and F, we can assume it to be of the third category. So this one could be ruled out. That's what is dummy encoding. Then for hash, so bringing into the concept of hash wherein we always have a fixed number of notations. So we go for hash encoding. This is useful when number of values or the categories on a particular feature grows more. Let's say you have a column A where you have 50 different values stored onto this data set. So creating 50 different columns might not be of use or may not be optimistic, and hence we go for hash encoding wherein you can fix up the number of columns that needs to be created to be either 10 or 15, in which case it is n. So that is what is hash encoding. So all the 50 values will get into those n number of buckets. Then last is binary encoding wherein each and every category gets converted into its binary equivalent. So that's what we call it as binary encoding, which can reduce the number of the bits that is used for storing. Let's have a short or brief look at the outputs to get more comfortability on the topic, and then we'll move on for the implementation. So label encoding, if you see, these are the actual data which I have given. So these are the grades. Grade starts with S, okay, and then A, B, C, D, and then E is there, F. Okay, so totally we have 7 grades. Yes, I am going to award 6 marks, let's say. F, I am going to award 0 mark. A is for 1, 2, 3, 4, 5, and then 6 marks, right? So after label encoding, see, all the S gets mapped down to 6. What is 10? 10E. E gets mapped down to 1 because I have encoded like that. So whatever you are mapping, automatically it will get encoded into that format. That is F. Since F is 0, I have started with E. So E will get awarded by 1, and followed by that D will get awarded by 2, and C will be by 3, B will be by 4, A will be by 5. So this is on one scale, this is on another scale. This is the action scale which I have used, where the grades gets increased as per the values. So that's what is the transformed data. Moving on to one hot encoding. Let's say if this is your actual data. Okay. So if we have the actual data like this, now just try to take the different values that this particular data set is having. One is Tamil Nadu, Maharashtra, Kerala, and fourth one is Karnataka. So automatically 4 different columns will get created. Tamil Nadu, Maharashtra, Kerala, and Karnataka. And wherever it is mapping, see, first entry is Tamil Nadu, so you'll get 1.0. So second entry is Maharashtra, it is 1.0. So this is one. When the fourth entry is again Tamil Nadu, so you'll get 1.0. Likewise, it gets mapped. Now moving on to dummy, the only difference is you can rule out one attribute and you can keep n minus 1. If n is the number of attributes, you can have n minus 1 in dummy. So whichever is not contributing to any of that could be assumed as that particular feature value. So that is what is dummy encoding. Again, the same data set, you can see the result of that. Okay, so what is missed out is Karnataka. Why? Because this encoding technique will try to pick out the unique values of the category or the feature and try to arrange in the ascending order. So which comes first is the Karnataka. So Karnataka comes first, Kerala stands next, Maharashtra. Just ascending order, that's all. Followed by Tamil Nadu. So this Karnataka will be ruled out, followed by Kerala, Maharashtra, and Tamil Nadu. So then how do we know which is Karnataka? When all the values are 0. 0, 0, 0 states that it is Karnataka. You can assume it like having the values ranging from 0 to n minus 1 instead of 1 to n. That's it. Then the hash encoding, again the same data set. If I fix my bucket to be 3, okay, so the number of hash value n is equal to 3, you will have only 3. So again the values will get mapped. Okay, so Tamil Nadu will get mapped onto the first bucket. Second value comes and hence Maharashtra to second bucket. Kerala attempted to third bucket. So that's the Tamil Nadu is again a repeating one and hence it is updating. Then coming to Kerala, actually all the 3, when the number of hashes or the rooms is given as 3 and we have completed assigning 3 different values to three different buckets. Now again it will go in a cycle. So 1, 2, 3 is over. So when the fourth value comes, again it will go and assign it in the same bucket. So fourth, if you take, it will again assign itself in the first bucket. Okay, why is it happening? Everywhere it is only the assignment of or the sorting of values in the ascending order. So you will get Karnataka, Kerala, then you have Maharashtra, and then you have Tamil Nadu. Okay, and hence once these 3 values come on the input, when the fourth one comes, it tries to accommodate in the existing bucket itself. Actually, there are various different algorithms that guide into which of the bucket it has to go, like MD5, SHA, and different algorithms. Actually, the basic algorithm that is being used here is MD5 algorithm. Based on that, this is being computed, and the attribute values will be stored onto the corresponding buckets. The final one, what we are going to see is binary encoding. Pretty simple. So the values will be converted into nominal values, and thereafter it will again be converted into binary values and get stored. Okay. So we have actually 4 data. One is your Karnataka, Kerala, Maharashtra, and then Tamil Nadu. So you will have values till 4. So since the first value comes in first, so you have 001 to represent 1. And then Maharashtra 010, it's the binary decimal equivalent of this is 2. Then this is 3. And again the Tamil Nadu, it is 1 since it is a repetition. And then if you take here 100 is the binary equivalent of decimal number 4. And that's how it gets moved on. So the advantage here is the reduction in the number of columns that you are creating. See, for having 16 different variables here, it's enough to have 4 different columns. But in other encoding techniques, you need to have 16 different columns or to a minimum of 15 columns. That's the advantage. So what we have seen till now is what is categorical data, how is it actually stored, then what are the different types of encoding techniques that are available, and let's move on to implement the same concept. Yes, so to start with, first we have to install a package called category encoders, which has all the different encoding techniques embedded with that. So how to do that? If it is a normal Python environment that you have, you can go to the Python prompt and type pip install category underscore encoders. So if you want to install in Jupyter Notebook, this is how: an exclamatory symbol followed by pip, then space install space category underscore encoder. So if you do that, you can see here, so all the requirements will get installed and successfully installed category encoders 2.2.2. You can see here. Once that is done, we move on for label encoding. It actually is useful when the value is ordinal. Now you can see here. Yeah. So what I did is import category encoders as an object, cat-enc I have created. Then pandas I have used to create a data frame. See here, in this example, I am going to create a data frame of my own. You can download a data set and then you can make use of it using this PD data frame itself, pandas itself. So what I have created is just the grades S2, S, A, B, C, D, E and F. Okay, so I have created a data set with the column name grades and the data of some 15 different students. Now, encoder is the object name which we are going to create for this category encoder. Ordinal encoder I am going to use. So how to create? It is ordinal encoder. To which of the column are we going to do this? It is for the grades. This will be useful when you are having an actual data set having multiple features. You can restrict on which of the columns to be used for this encoding. Return data frame is equal to true. Yes, we need to override that data frame. Mapping. What is the mapping? See, there are 2 ways in which you can use. If you give a mapping of our own, let's say I have given a mapping like this. F needs to be mapped to 0, E to be 1, D to be 2, C to be 3, likewise. Or else if you are not giving this mapping, it will automatically assign as and when the value comes in. So I'll execute both and show you. So then I have printed the actual data, and then finally we have done a transformation on the data. So how to do? We have already defined the mapping for the grades. Now if you use this fit transform function over this data, all the values will get mapped onto their numerical equivalents and the value will get stored onto data underscore transform. That is what I have printed. Now when I execute this, you can see the output. See, this is the actual data. I have 15 students' grades and this is your transform data. Okay. So the transform data, if you see, 0 gets mapped on to 6 because it has yes on its way. Now, I'll remove this mapping. I'll make this to be the comment statement and then this I'll open. I'm not giving a mapping of my own. So it will take of its own. Okay. Let us see what is the value that gets mapped. Yeah, here also we have to give hash. Yes. So you can see here, I hope you can able to view. So this is the first data, okay, and hence it gets automatically transformed to 1. The second data will get transformed into 2, 3, 4. Likewise, as and when the categorical values comes in, the values will be incremented. So you cannot assign your preferred ranking on the data. If you want to use it like so, you have to give your mapping. That's the difference. Moving on to one hot encoding. So when you have nominal values, as we already saw, when there is no ordering among the elements, usage of label encoder may not be perfect since it may enforce rank ordering among the values, and hence we go for other encoding techniques. The same here we have used in category encoders and pandas. Here I have created a data frame with one column, the source state from which the student are coming from. Okay, so and I have 10 different student data. Somebody is coming from Tamil Nadu, Maharashtra, Kerala and Karnataka. Now, like the same, we have to create an object for category encoder dot one hot encoder. Earlier we have used ordinal encoder. Now it is one hot encoder. What is the column? It is source. Okay. Handle underscore unknown is equal to return underscore NaN. Meaning that if you don't know what to do with particular thing, it can return NaN. Okay. And hence we are asking the return df to be true to override the data. Then use cat names is equal to true. Yes. Now we are printing the actual data. Then once it is transformed, okay, so you are applying the function over the data, then we are printing the transformed data also. So you can see here for the number of values, if n is the number of values that you find on your feature, that many number of columns will get created, and whenever applicable you will have 1.0, rest of all will be 0.0. When Maharashtra is there, you can see here it is 1.0. When it is Kerala on the fourth, you can have, Karnataka on the fourth row, you can have 1.0 over here. So next comes your dummy encoding. Again, it's a similar kind of encoding technique with the removal of one value of an attribute to reduce the number of values. So instead of starting the values, the attribute values from 1 to n, now we are going to go from 0 to n minus 1 so that you can reduce one column storage. So this is available in pandas itself. Okay, you don't need to have this category encoders for that. It is available in pandas itself. So again the same data frame I have used. So it is like pd.getDummies. The function that you need to use is getDummies of what is the data. Drop first is equal to true. Are you in need to drop the first attribute? Yes, I want to drop. That's what drop first is equal to true. What it will do is it will try to take out the values from the particular column, arrange it in the ascending order, and the first attribute alone it will make it as 0. Okay, and while getting stored we could see, okay, so while arranging in ascending order, Karnataka comes first and hence it is removed. So this Karnataka alone will be shown with the value of 0, 0, 0. Rest of all goes as similar to your one hot encoding. Then comes hash coding. So what we did, rest of all are same. So we have used hashing encoder function, the column being the source and the number of components to be 3. Okay. So what does it mean? 3 different columns it is going to create. Okay. So instead of single column, now it is going to create 3 different columns. Again, we are applying this fit transform function. and let us see how it works. You could see column 0, column 1 and column 2. This works on MD5 algorithm. Okay, so Tamil Nadu gets into first bucket, Maharashtra into second bucket, Kerala into third bucket. When it comes to Karnataka, you can see it gets aligned with Kerala. Okay, so that works on MD5. And if you include one more, let's say if I'm going to include Punjab and I execute again. Yes, coming to the output, let us see into which of the bucket it gets aligned. So Punjab gets aligned to near to Tamil Nadu. So that's how it works on. Then comes the last encoding technique for this session. It is binary encoding. So every value of the attribute will get mapped onto a binary value. That's all. So it is working using the function called binary encoder. Again, the column remains source. So we want to replace the source function. So you can apply the fit transfer function over the data. Okay. And then we could see here Tamil Nadu is equated to 1. The binary equivalent of 1 is 0, 0, 1. Then Maharashtra. So how does this number of columns gets decided? It is based on the number of values that it has. Actually, the value needs to start with 1 and hence it needs 3 bits. 4 values Tamil Nadu, Maharashtra, Kerala and Karnataka. Starting with 1, you cannot represent using 2 bits. Okay, and hence the third bit is being included. So, and the second value Maharashtra is represented using 1, which is the binary equivalent is 0, 1, 0. 2 corresponds to 0, 1, 1, which is Kerala. And the fourth one, the binary equivalent is 1, 0, which is the equivalent of 4. Thank you. Let's learn together. Keep watching my channel. Thank you.